So as people are joining, I think we will start in maybe 2 minutes. Uh, but I just wanted to say that over the last 3 days and over the last 6 sessions, we have had phenomenal participation from people. And all the days it has been 100 plus people who have been joining. And in case we are not able to answer any of the questions that you are putting in, I request you to either send it to us or there are the WhatsApp numbers on the webinar as well, uh, on the webinar page. Please do write into us. And we will be sharing all the session recordings as well as the few reports through to you as soon as the webinar sessions are completed. Hope even today we'll be having at least 100 plus people joining in because this is one of the hot topics, CBG and biomass in particular. And Prithvi has lined up a stellar set of speakers. So Prithvi, we can start.
Yes. Oh. So yes, good morning everyone. A warm welcome from SolutionBuggy. My name is Prithvi. I'm working as a senior project manager here in SolutionBuggy from 3.5 years. So hope you have attended all the previous sessions under the AIM, that is accelerating innovation and new ideas in the manufacturing. So as I told, until now I had a sessions on specialty chemicals, sustainability chemical products, and F&B and packaging sector. So today we'll be focusing on the bioenergy sector in the first session and on the project management in the second session. So before that, a quick introduction of SolutionBuggy and what we do. We are India's largest dedicated platform for the MSME sector, empowering thousands of industries with expert solutions over the last 9 years. So onboarded 10,000 plus highly skilled experts as consultants, engineers, trainers, or industry veterans, executed 3,500 plus projects across diverse manufacturing domains. So our end-to-end project support covers every stage of industrial growth, including consulting and training that might be lean management, quality improvement, process optimization, etc. So new industrial setup from concept to commercialization, the turnkey assistance, market research, and product identification, which is a unique one that will be explained in the next session, and detailed project report to submit for the banks or subsidy loans and all other even private investors as well, and feasibility studies to analyze the knowledge of the product. So machinery procurement and plant setup, which is again under the turnkey assistance, commissioning and operational support training, and even for managerial level hiring as well. So even that includes supply chain and sales and marketing assistance, strategy planning. So whether you need a one-day expert consult or a full-fledged industry setup, we connect you with the right professionals to ensure the success. So next, I would like to thank all our associated strategic and media partners and the government of Karnataka for encouraging us in the running this webinar sessions. So the topic we'll be focusing on the next 1 hour is the Napier grass. So which is the most important thing and the trending thing right now in the energy sector, which is used again for CBG or biomass briquettes and pellets. And the unique which is technology oriented and futuristic as well. The topic is biochar, and what are various value additions that can be done and the opportunities in domestic markets. So we will be covering the various aspects and the upcoming trends in the sector. So let us introduce our speakers. Next slide. No, previous. Yeah. So we have Mr. Shivshankar sir, who is now the Managing Director of Bioenergy Board, State of Karnataka. Sir, we welcome you.
Good morning, everyone.
Hello.
Hi, is it audible?
Yeah, now it is audible, sir.
Okay, thank you. Thank you for inviting me. I am happy to be part of this discussion, and the future of energy and energy consumption leans towards bioenergy to a greater extent. and a lot of work has been done. And now the technology industry is gradually picking up in India. And they're happy to add to the further discussions. Thank you.
Yes, sir. So, from the state of Karnataka, so we are, I mean, in the terms of government of Karnataka, also planning like other states for the bioenergy with respect to biomass or bio CNG. So how even the manufacturer and as well as the agricultural aggregator can be happy in terms of the output for the manufacturer as an energy product and output of the as a crop from the crop. So, please next slide. So I would request Shiv Shankar sir to explain in brief. So what can we expect from the state of Karnataka in terms of subsidy and as well as managing for the manufacturer and as well as for the farmers as well.
I request the audience to be very sensitive about the word subsidy because these are the words which have misled many people. It is only if there is a passion in the industry and if you are really committed to uh, come up with manufacturing and you want to have a proper forward and backward linkage, that is the entire supply chain, uh, then only this field is the right field for you people. And coming to subsidies, Government of India, Government of Karnataka have their own policies. If it comes to bioenergy, Government of India has two schemes called Satat and Gobardhan, under which biogas production has a subsidy where it is an output-based subsidy, and roughly 86 lakhs per ton of output has been prescribed by the Government of India. And similarly, Karnataka's industrial policy as of now prescribes around 20% of the uh, plant and machinery part. And we are hoping that Karnataka's new biofuel policy will take up soon. So if that comes into picture, an additional 4 to 5% of increase, or roughly a 25% of total uh, uh, performance linked the incentive may come into effect in a month or two. And that will be a very big boost for agro-based industries. And we are very particular that the farmer gains earns more with even the waste which he is not utilizing as of today. Example, the sugarcane toppings, trash, unutilized paddy straw, unutilized maize cobs, unutilized cotton uh, uh, plant material, and so on. Where as of now, where the farmer is not utilizing the uh, non-economical part of the agricultural, horticultural produce, he should also earn from it. And it should help in creating a circular economy where the surplus waste and the forest waste uh, are taken care in such a way that it creates a circular economy where the byproducts come back to the fields as fertilizers, enriched manures, and other additives, so that the complete cycle of soil health is taken care, vegetation is taken care of, and also there is a new dimension which can support to a greater extent to the bioenergy sector, uh, coming to pellets, briquettes, biocoal, biochar. Biochar is an additive to the soil and also a supplement or a substitution to the petroleum products. then purification equipments, and so on. Biodiesel, which has an oil as an primary feedstock, which is primarily non-edible source oil. So we are promoting tree-based oil seeds, then used cooking oil. And now we are even targeting other sources of raw materials such as acid oils and the edible oil refinery waste, which are not used for edible purposes. And some work is also going on algae-based oils, insect-based oils, but they are in the pipeline, which may come up in over a period of time. But here, ultimately, the farming community, industry are both in a win-win situation, and this will help India in becoming carbon neutral, have a sustainable energy path, have a circular economy, and also encash on the carbon credits which are available on all these products. Thank you.
Thank you, sir. It was a good explanation, and we are expecting the policy by this month end. So it will be very much helpful for the manufacturer and as well as the farmers also, where the farmer can expect some quick returns. So next slide. So now, as Mr. Shivshankar informed about the farmer, and he mentioned one particular word which is called the carbon neutral. So what can be done to increase the carbon content in the soil in terms where the output of the product or the crop obtained to increase the output of the crop? So we have to practice the organic way of farming, and which the major thing where in terms of commercial crops now in this era which is trendy is nothing but the Napier grass. So how it can be grown and how the output of the grass can be increased by using the organic farming. So our the next speaker, Ms. Sejal Maheshwari from Gujarat. So she's an agricultural enthusiast, and also she has helped a few of the farmers across the country where they're not only Napier grass, other than even other crops also, cash crops, that to increase their, she has helped and her team. So they have helped them to increase their output of the crop. So we welcome you, ma'am.
Thank you, Prithviji, for
You can just
having this
start
session.
with the introduction and then get into the next future slides.
Sure. Am I audible clearly?
Yes, you're audible.
Okay, sure. Thank you, and thanks for inviting me to the sessions. And I also very much interested to talking to all these peoples. And the main why, because as starts with introduction, my name is Sejal Maheshwari. I'm from Gujarat, and by profession, or if I say by education, I'm a software engineer. But yeah, I love being with nature, from virtual world to the nature, and that's what it brings me. How the agriculture is the first step, we can say, for connecting to the natures. And I starts with that also a part of this discussions, that everything when we talk about any kind of farming, right? Everything, it starts with the good quality of fertilizer. And when we talk about good quality of fertilizer, it starts with the cow. So my project started with how to generate income from cow. It's because that's the only way to make any goshala sustainable. So we as a team work on these main 5 things, like how we can increase the goshalas and farmers income, how we can improve the soil carbon and fertility, how we can solve the malnutrition from the which is a very wide issue all over the world, how we can produce energy from the farm, and how we can solve how we can do the farming from the saline soil and the saline water. So very first thing is everything goes around how we can improve the carbon inside the soil. Why we say the carbon is so much important? There are 108 other elements are also equally important, but they all are in a ratio proportionate to the carbons, right? So we need to work on improving the carbon. Ideally, the carbon percentage should be like 18%, right? But right now, if we take Indian average soil carbon, then it is coming to 0.3. And yesterday only I have a word with someone who is from Bikaner having the carbon of 0.01%. So consider how we have depleted from 18% to 0.1%. So that's the problem. And that's why our fertility is decreased so much that we are not able to get good products. I have almost, we used to conduct seminars for the organic farming for the farmers and conducted, met nearly 1 lakh farmers. And what I learned from everyone, if I say the common issue of the farmer, then it comes only when that if they are doing chemical farming, the cost of production, the cost of farming is getting increased, because earlier they used to put 2 bags of urea, then 4, then 6, then 8, then 16, and gradually the fertility get decreased. So that is the core problem with the chemical farming, because it makes the land completely barren, saline, and also reduce the fertility. And then it comes to the organic farming, but we don't have the right method of organic farming. Because of that, it says that it requires at least 3 years to move from chemical farming to organic farming or natural farming, and no farmer can sustain 3 years of waiting period. So we need to have some good methods where they don't even need to wait for the 3 years to make their soil fertile, and from first year itself they can start with the natural farming, not just equally get the yield but also increase the yield day by day. So that was we started with, and how we can achieve this, right? If you ask right now anyone, you always listen like it takes time to convert from chemical to natural, but there are certain effective ways from which we can convert immediately from the chemical farming to natural farming and without compromising the yield. Now, why I'm talking so much on the natural farming, we all know, but that is the base, right? The only because everything we talk about the energy crops right now, we are talking on the Napier or anything else, right? If our soil is not fertile, we won't be able to get that much yield. Okay, so for that reason, our soil should be fertile. If we study some of the researches, you will find that many have claimed that the UN reports or they have claimed that by 2030, many of the soil just become the barren. Even the germination cannot happen to the soil. So with that, we need to work on, and this is a need of an hour, to work on our soil fertility to get the produce which we are looking for. We are right now talking more on the Napier, but it applies to everything. If we work on our soil, if we make a fertile soil, then rest any crop can be, we can grow up to the good level. We choose Napier farming as well because that's the energy crop, and that's also as a cow feed and cattle feed. So it works for the both, and for that reason, we do the Napier farming. Now, when we say that how to do this natural farming, what are the correct way? So very first thing which we do is with the, if we take the center, then it comes to the cow. Why it comes to the cow? Because the reason is, we talk of natural farming, organic farming, sajiv kheti. There are many terms around this. But what comes in picture when we talk on sajiv farming or jaivik kheti, the terms comes as a jeev, right? And that is what the microbes are. So our soils should need microbes to grow. Because these are the microbes. So if I say my body weight is 100 kg, or by volume, if I say 100 percentage, then 97% of my body volume is consumed by the microbes only. They exist in my body as well, and same for the soil as well. So we need microbes in our soil. We used to have, I mean, in previously, we used to have, if I take a pinch of soil, it should have 200 crores of microbes minimum, right? And right now, if we take it, it's nearly 50,000. So we need to improve the microbes, and that's the living thing inside the soil, and that makes our soil live. The problem is we don't have that microbes right now. We don't have the methods from where to get these microbes right now. There are only two possibilities till now what we have studied. That one is the cow and other is the rainwater. These are the two things which are important for the soil microbes. And that's the reason we studied on the cow. We identify that before doing some of our practices, I talk more also that what are our practices, but before we have taken a Gobar Gaumutra report of any cow which is on any from Gaushala or any from street cow, we identify, we hardly find 5 to 10 types of microbes in their Gobar and Gaumutra, right? 5 to 10 types is very less. So we started improving on the gut of the cow. We started working on that. Why do we have just 5 or 10 types of microbes? Because we have never fed anything good to the cows. Earlier, cow went to the Biochar land and they used to eat something good and medicinal plants according to the nakshatra. They used to have more feeding on the grasses because cow is a grazing animal. So for that sense, these microbes are automatically developed inside the cow's body, and ultimately we receive in Gobar and Gaumutra. But the problem right now is the Gochar is no more available, right? We as a human acquired everything. Rest is we are not feeding anything good to the cow. We are feeding just whatever the residue is available in the market. And for that reason, their gut is completely disturbed. When we start with the organic farming, we say if we use Gobar, our land can be fertile. And that's why it takes 3 years or more than that, because that Gobar does not have that much potential anymore, because we have never fed anything good to the cow. So our process start, for that. So in our experiment, after having this, we did some process, like we followed some package of practice where we fed cow with Suvan Prashan live water. And I come to that as well, what is Suvan Prashan live water. But we fed this cow to organic grasses or grasses which are grown without utilizing any chemicals. And after doing 3 months of these practices, what we identify that cow gut is so clear that there is no foul smell in their Gobar and Gaumutra. And if someone visits the someone visits the Gaushalas, which we are following their practices, you will personally realize that there is no such foul smell you can see at the Gaushalas. And after that, if we do the lab reports over a period of 6 months, we have identified there are 50,000 plus varieties of microbes inside the Gobar and Gaumutra, and one complete Rutu Chakra of monsoon completed. And we at the end of 1 year, we identified there are 1.125 lakhs of microbes in the cow's body. So that Gobar and Gaumutra, when it is a microbial rich, and after that we make a fertilizer out of it, then again it goes to the soil and they do perform their job. They multiply, they eat, and the food of these microbes is the carbon, the organic carbon, if I say, right? So for that reason, it's a circular. So we don't have a control over the rain from where we can get the microbes, but we do have a control over cow. We should get the good quality of Gobar. We get a good quality of microbes. These microbes come to the soil, they multiply, they play there. And the important role of this microbe is why we need a varieties of microbes, right? That is one major. We need a high quantity of microbes. Also, we need a high varieties of microbes as well, because these microbes are like antibodies in our body. Like if I get affected with the corona's antibody can work for it and it protects me. Same way, any different type of disease in my body, there is a different types of antibodies. the antibiotics it produces by itself. So same way on the soil, some microbes are very comfortable with the morning good temperature, some microbes are comfortable with peak temperature, some microbes are comfortable during night period, some are during humidity, some are during monsoon. So these are only four, five things which I can speak up of, but nature has a n dimensions, right? And for working against these n dimensions or complement these n dimensions, there are n type of varieties of microbes. If our soil does have all these microbes, then only it can play during that condition. They can protect our soil during that conditions, and in that way our soil can be can take whatever available during that situation, and it makes our soil fertile. And the microbes for this soil, if I say, it's an organic carbon, right? The carbon which they can digest. And for that, the major things which work is a liquid carbon or a liquid LFAOM. Now, before coming to that, I can work on what is the Suvarnprashan and what is live water biochip. So Suvarnprashan is a liquid which consists of 931 varieties of medicinal plant. Every day we feed that cow 10 ml every day, because it's not possible for everyone to get these much varieties of medicinal plant. So instead of that, we are producing by ourselves, and if anyone can want to procure it, they can procure it from us, which consists of 931 varieties of medicinal plant, and these are also harnessed as per the nakshatra. So these actually mainly work to cleanse or detoxify the cow gut. Second point is come as the biochip, that is live water biochip. Now the purpose of live water biochip is that our body consists of 70%, not just our body. The earth itself has a 70% of water, and everybody has a 70% of water requirement, right? Whatever, if I eat something bad food, my body still can sustain. But if I drink a very bad quality of water just in a 10 ml of I possibly, there are higher chances that I can get hospitalized because of that, right? So water, because it is a raw, it directly mixes into our soil. There is no processing system for the soil. Yeah, kidney filtration is all there, but yeah, it affects so much. So water is very much, it has a 70% role in our body as well. So we need, most of the time in farming, we focus on fertilizer and many things, but we don't focus on the water. So, and not just for the farming, from ourselves as well, we drink any kind of water, for cow as well. So that's a problem. Water needs to be purified. So what does this water chip does? And again, I say, we don't drink high TDS water, right? Like the problem with is that TDS is not decomposed in our body. Hardly we drink a 150 to 200 TDS of water, if I understand. But the nariyal, what we say, coconut water, right? It has a 5,000 TDS if it is from the Kerala shore, that we can easily digest. Then what's so TDS is not a problem. The type of TDS, or I would say the structure of TDS, is a problem, that our body cannot digest the TDS if it is not in a bioavailable form. And these TDS actually is a very nutritive in a sense that it many salts can be taken from this water only. So the job of this live water biochip is to convert this TDS into bioavailable form, so our body can digest, our body can get lot many minerals from the water itself. So that's the job of live water biochip.
Okay, let's go for the next slide.
And what after performing all this, and there is one more thing, that how to feed cow. There can be many discussions on that, but considering the time, let's discuss that after following the practices, what can happen to the cow, right? I mean, what complete differences we can see, that it enhances the cow health and the environment. up to it improves the cow's health and ultimately reduces the veterinary cost. It improve the beneficial microbes into their gobar and gaumutra. Their gaumutra, even if I sometimes share the reports, it has a good quantity of gold, ionic silver, calcium, iron. So whatever the important nutrients our body is required can be received from the gaumutra only. But one should take the gaumutra only if the cow is detoxified. Otherwise, we are going to get a lot many other pesticide residual into our body. Other is it improve the milk quality, milk taste, milk quantity. It also improve the shelf life of a milk if it is a milking cow. And other than very much important thing, as in the first slide we discussed on the nutritional part, that the solving malnutrition is one of our pillars. So malnutrition can be solved only if these much good quantity of microbes, good water can get into the soil. These microbes can improve the nutritional value to our crop, and ultimately it serves to the society. And this can be a circular economy, and we can get a good quantity of microbes, good quantity of nutrition from our crop. So yeah, these are all about the benefits of organic farming. Okay, now we talk about charts of CBG and biomass, that how it we discussed a lot on the cow and what are the practices, but why we are doing this, right? People generally don't care for themselves. Why they care for cow to have to giving them a good food and all, right? It's only because we want a good farming. Like, I love cow, but it's not necessary that everyone pays same attention. But at least if we are in this business, right, we need to take care of these things to get a good yield and the good soil. Because Napier, if I talk about the Napier, is a 20 years crop. It can be, 10 years is minimum. It can be 20 years crop itself. But only if the soil carbon is maintained. If we are just draining out and we are not putting a good fertilizer inside it, our crop may not sustain. So we need to follow the practices. We need to produce a good quality of fertilizer so we can get a good quality and good quantity in our farming. And if we talk about the process flow chart, just a minute. Okay, so if we talk about the flow chart, then as like for animal detoxification, where we fed cows with the sumarpration, live water, biochar water, treated water, and good quantity of Napier, and there comes the grass farming comes. From this Napier, we can make multiple products. Napier is a we can produce a biomass pellet, cow feed pellet, raw biogas, electricity, CBG, leather, biochar. There are multiple things can be produced from the Napier, and this is why I take into account the Napier farming. And if I say by doing the practices which we are doing, we are producing a liquid fertilizer using an anaerobic tube. And why the liquid fertilizer is much more important, because it directly penetrates inside the root, right? So good quality of fertilizer can be produced, and if it is in liquid form, it can directly get inside the soil, and our soil fertility improves. So over the period of time, we are following these practices, and right now our soil carbon is the 6%. So that way we can improve the soil. And what's the other flow? Like Napier farming, we can produce the biomass pellet. This can be of two types. Either we can go with the fodder pellet, either we can go with the cow feed pellet or any cattle feed pellet. And these are, very first thing is, these are 100% organic, which is right now not available into the society, because we are not using any kind of urea, DAP, pesticide, chemicals. in growing practices. So if we even talk of the biomass pellet, the fuel pellet, right? When you burn it, it doesn't releases any other than anything CO2, and this CO2 is also breathable by the plant. So if we follow the whole practices, we are not anyway producing any hazardous gas for the society. And following this whole practices, like if we do the pellet or we do the CNG, we are entitled even for doing the farming as well, and even for producing the raw biogas. Sir has mentioned that we can be eligible for the carbon credit. So carbon credit can also be achievable. So it's a win-win situation in every directions. So like for bio CNG, if we say, okay, do you want me to explain this as well? Like how to produce a bio CNG? Can I start on this, or?
You can take the 5 minutes, ma'am.
Okay, I can take 5 minutes, right?
Yeah.
Sure. So, from Napier, how we go to this process? So we've chopped Napier grasses. For doing a bio CNG, there are the two methods. One is we directly use this Napier grass and produce the raw biogas, and raw biogas can be filtered to the CNG. Right, our process is so efficient that from 15 kg of Napier grass we can produce 1 kg of CNG, and which is generally 25 kg to this one. It's only because of that anaerobic tube digestion system, because there is again a lot more to discuss on that. But if I say in short, the CSTR model has some challenges which can be solved with what is the tube-based system, and for that we can achieve that much quantity. It's nearly 6.6% of conversion ratio we can achieve through this particular method. And again, there are different varieties. If Napier has a 200 plus varieties, so one should be cautious when you start with the Napier farming. It can be for cow feed, it's different. For fuel, it's different. For CNG, it's a different variety, because ultimately, if we are looking for biomass pellet, we should know what is the calorific value of that particular Napier grass. If for the CNG, we should know what are the lignin, cellulose, hemicellulose percentage. If we go for the cow feed, we should know the protein percentage. So every Napier has a different varieties, and we should be cautious enough to choose the correct variety while doing this Napier farming. And at our locations, we are able to take more than 600 tons per acre per year for the Napier farming. This is saying I'm at the conservative side, which is, I guess, minimum four times what generally people are getting. It's only because our soil carbon is so high, and we work on improving the soil carbon. So if soil carbon is high, then only we are going to get this much this much yield. And from SA, if we say for the biomass pellet, what's the flow? Then we get the Napier. First, we take Napier has a 70% liquid out of it. With our machineries, we can take at least 55% of Napier liquid out of that, and there will be a solid percentage. From solid percentage, we make a pellet. It goes to the pellet mill, and we need to dry it first where we need to reduce 10% more moisture. Then it goes to pellet mill, and we make a pellet out of that. And whatever the 55% liquid we have extracted, that get into that anaerobic wax, where it generates a raw biogas from this liquid, and the generator can be run on that gas, and the pellet mill can be 100% power free by using just directly to the raw gas. And that liquid, whatever receive, we can enhance that liquid and make good quality of fertilizer. And right now government is purchasing that fertilizer at 1.5 rupees. That is the minimum cost. We can sell it up to 50 rupees or more than that. We are selling at 50 rupees or 60 rupees or 70 rupees. There are different people are selling at different rates. It depends on what's the quality of these fertilizers. So this can be achieved. It's a completely solution can have, if we say all this project, the ROI can be achieved within 2 years. So these are the good projects. I think you can, during these sessions and connecting with the SolutionBuggy can give you the whole picture that how this can be achievable.
Sure. Thank you, ma'am. Thank you very much. That was a brief explanation. And for the attendees, so the whole agenda or the conclusion of the explanation what Ms. Sejal had explained is to increase the carbon content in the soil, and by then the next level, the crop output would be automatically, it will increase by next 12 months, 12 to 15 months. So that's the next, that's the whole agenda of thing. And then now we'll enter into the manufacturing of CBG part. Next slide. So our director, Mr. Guru Prasad, is here. So he's our director at SolutionBuggy and have 20 plus years of experience in consulting. So Mr. Guru Prasad has completed BE in electronics and an MBA from AIIM Bangalore. Guru sir, over to you.
Thank you, Prithvi. Thank you, Sejal ma'am, and thank you, Shiv sir, for introducing the entire concept of bioenergy. We closely work with Shiv sir as well and with Sejal madam as well to help not just in the CBG sector but also in any kind of bioenergy sector. Next slide, please. Yeah. So I think with so much of emphasis on compressed biogas, the entire process, I think Sejal ma'am also briefly mentioned, wherein there is basically a digester where the raw material, which could be anything from how Shiv sir said, it could be sugarcane press mud, it could be paddy straw, or the MSW, or it could be even lantana grass. So any bioorganic material that can be eaten by the bacteria is fed into the digester. Of course, there are some pre-processing involved when it is Napier grass, or when it is MSW, then there is some other process. So beyond that, just to give a layman's view of how the entire flowchart works, once the digester, the bacteria in the digester starts eating the organic material, it starts producing gas. So, as a simple process, it takes about 30 to 45 days to make this gas. And once the gas is made, it's basically methane. It has some impurities, for example, hydrogen sulfide and things like that, which is then, cleaned. Of course, there are different processes for this. CSTR is one of the process, and then it goes into a VPSA tank, and the cleaning process happens. Water scrubbing is done. And finally, the gas which is produced is the biogas. Now, once this biogas is compressed and filled into cascades, it becomes the CBG. The entire concept is that along with the biogas, you also get some byproducts, like how ma'am was mentioning. It is the organic. It's basically liquid FOM. Which is then either marketed directly, like at rupees 1.5 per kg, which the government is giving, or you can make organic products out of it and sell it at higher prices. This is the byproduct. Your CBG itself, as of today, sells for, I think, about 70 plus rupees. It's again linked to the CNG prices. Also, because the government is now mandating that all CNG bunks should have a mandate of at least 10 to 20% based on the state in which you are, which has to be fed by CBG. So this is where the opportunity for an entrepreneur today is to get into CBG. He can, get into either making the CBG and then supplying it to it could be the Horeca segment, or it could be the CNG bunks. Or the other option is, if you have a gas line which is coming near your location, wherever you're going to set up the unit, then it is an added advantage that the CGD which is there can be, you can go and directly pump into this CGD. So these are basically gas distribution networks, and you can go and dump your whatever CBG you are making into these CGD networks. So this is the basic flow chart of how you start from the raw material, make your CBG, and who is the a buyer of your CBG. So with this in mind, if somebody wants to start the project, then what are the few things that he'll have to look at? The first thing is basically the feasibility analysis. Although the timelines that are mentioned here, it can be done on an overlap method, and few things can be overlapped with each other. So give or take, it's about 1 to 1.5 years. The entire project should be right from concept to commercialization can be done. Initially, what we suggest is we need to do a feasibility study of the land wherever you're going to set up this unit, because we have a few key concerns which we'll be addressing in the next slide, which have to be looked at. Post that, we have a technology selection that has to be done based on the kind of raw material availability. Are you going for cow dung? Are you going for organic waste? Municipal solid waste, or is it Napier grass? So based on these criteria, a few technologies will change. Post that, it is the documentation, the process. Obviously, you need a proper DPR to avail bank loans and get the MNRE schemes, etc. Get your EC and the PESO approvals, and then you can proceed with the actual construction and installation. We also assist in trial production and getting the final production in place. We need to understand that unlike any other manufacturing setup, this is not just machines running, right? So because there are so much of bioorganisms involved, it could be either at the raw material side or at the feeding side, where the microorganism needs to be controlled. And based on all these aspects, the purity and also the percentage of methane in the biogas can vary. So it is very imperative that somebody setting it up, it is not somebody comes in and installs the machinery and goes and then it starts running, right? So you need a person to be with you to understand. It could be either a bioscientist, or it could be from the consulting firm itself, who will be able to assist you with getting the right production levels. Of course, it can't be achieved in 1 day or 2 days. It needs some time based on the kind of raw materials that is being got. So we need to alter the various parameters and make sure that the efficiency is at the highest. Next slide, please. So as I said, there is a location identification that needs to be done. The main criteria, if you can see in this slide, are mainly how far are you from the Napier, from wherever the grass is being grown, or if it's the organic waste, how far is your location from that. We would suggest that you be as close as possible, because it is a bulky raw material, and transporting the grass or even the organic waste over large distances becomes a logistical nightmare. The second thing is your offtake bunks, where you're going to go and offload your CBG, should not be more than at least 50 kilometers, because more than this, then your logistics costs can go higher. The other option which I said was you should be either close to a bunk, or you could be close to a gas distribution network, which makes your pumping into these networks easier. Next slide. So I think with this basic idea of who's going to be your buyer, at least in that case, since the government and the OMC, the oil marketing companies, become your buyer, one thing is clear, that you do not have to, unlike other industries, you do not have to go and start searching for buyers, unless you are making a lot of quantity and then your nearest bunk is very far. Then in that case, you need to look at private buyers, Horeca segment, and things like that. Otherwise, at least you know that the price of procurement is fixed, and who is your buyer, because the OMCs also give tri-party agreements which are long term, to the tune of 3 to 5 years. And this at least takes the headache of searching for a buyer every time you are making the CBG. So having said that, the government, as sir was mentioning as well, there is a lot of incentives from the government. The biggest one being from the Ministry of Non-Renewable Energy, MNRE, to the tune of about, the policy says for 4.8 TPD, then it's about 4 crores. So that works out to about 1 TPD for about 84, you get about 84 lakhs. Beyond that, there are schemes which are in terms of the electricity subsidy that you can take, or it could be when you're growing the CBG. I mean, when you're growing the Napier grass, you could look at concessional tariffs for the farm equipments, which some of the states are offering. For example, if you look at the state government schemes, UP government has had a very good policy which came in very early in 2022. Like how Prithvi was mentioning, Karnataka government is also coming with a new and renewed policy, which is going to be better than the current policy. With respect to the UP government, the UP NEDA, that is the UP New and Renewable Energy Development Authority, has come out with this policy that you will get about 30% of your capex for the farm equipments will be provided by them, and to the tune of about 75 lakhs per TPD, the capex will be offered as subsidy. All these are production linked incentives, so it is not like you will get the subsidy as soon as you start. It is after you start producing the gas. Another state, Odisha, has been a fast mover on this, and about I think it came out in 2022 as well. Government will be leasing out land at the rate of at very minimal rate at 2% of the prevailing IPR in that region for 25 to 30 years, and the same the subsidies in electricity for 15 years, low cost no cost on the stamp duty if you are going to register the land, also the other benefits that are available for other manufacturing industries continue. So I think from a policy perspective, a lot is being done either through the Satat or the Govardhan scheme as well. And to make it more sweeter, many of the states are offering individual incentives so that the government's initiative of reaching 20% blending by 2030 of CBG with the compressed natural gas is met. Next slide, please. So if you look at a very broad kind of a back of the envelope calculations, of course the ground level realities can change a bit, but we expect that for a 3 TPD plant, I suggest 3 TPD because the Satat schemes becomes applicable only for 2 TPD and above plants. So if you want to go for an economically feasible kind of a plant, this is the minimum that you have to look at. And the plant area need not be very high. Although we have mentioned 2 to 3 acres, it's basically can be set up within 1 acre also. The larger area why we are telling is we need to stock up on raw material, and India being monsoon prone for about 4 to 5 months, we need covered area to dry up these Napier grass and or even the organic waste and things like that. So we need a slightly larger area. The next is the farming land. In case you're going for Napier as your raw material, typically in conventional Napier, it's about 80 acres. But with how ma'am was telling about the change of farming practices and going for that kind of farming, it can be reduced by about 50%. Next, the cost of plant and machinery can be looked at 12 to 13 CR. We expect the total investment to go up to 15 CR because when we make our DPR, we are also projecting about 6 months of holding cost for the raw material and inventory. So this being the basic plant setup cost and the area required, all the government subsidies are applicable to these kind of plants. The other this one will be shared with you for other capacities. You can have a look at it. Also, it is not mandatory that we have to go with Napier grass. It could be an integrated plant where we go with cow dung, or it could be availability of MSW, that's a municipal solid waste, then that can be used as well. So a host of permutations and combinations can be done, But again and again, we would like to mention that it's a bioorganic based, plant. So you will not be able to change the raw material day in and day out, because it's a microorganism which is going to eat the raw material. You can't put it in a bioshock kind of a situation, and it stops producing the gas. So you have to be very careful on that aspect. Beyond that, I think there is a possibility to have an integrated plant which can be looked at, and we can have multiple feedstock possibility as well. Next slide. Yeah, so I think that's the scenario on the CBG sector. I know it's very brief. It has been splendid talking to you. I would now hand it over to Prithvi to take you through biomass briquettes and pellets and Biochar as well. Any other questions that you have, please post it on the Q&A window, and we will try to answer as much as possible. Over to you, Prithvi. Thanks. You are on mute.
Sorry. Yeah, thank you, sir. It was wonderfully explained about the bio-CNG and its criteria and explanation and all. So coming to the talk of the town across India, that is biomass briquettes and pellets, especially the pellets plant. So the reason being, it is used for both the purposes, where the government NTPC plants or the normal state governments power plants, where the coal can be replaced through pellets. That is one the major region, and the other major thing is the private companies, whether it might be chemical companies, food and beverages, textiles, or any other manufacturing companies where used. So for these reasons, either pellets or briquettes are most profoundly used. So coming to the difference between, so what is pellets and briquettes is the most easy and the most important point is the size of the product, where the pellets are compact, tiny products for automated heating systems. That is, it will be around 6 mm to 8 mm only, and the size is standard, and hence due to this standard size and all, it is profoundly used in the NTPC plants, especially government organized plants. And briquettes, it's very large in size. It can go up to 25 mm of size, and it is closely compressed blocks for industrial and power generation also. Even this can be used, but due to the size effect, most probably the government will turn towards the pellets manufacturing plant only. So briquettes are extensively used in the private companies, where the size of the pellets or the briquettes, it doesn't matter. So pellets are ideal for residential and commercial heating, and as well as the power plant. The calorific value will also be very high. And when it comes to briquettes, yes, it's also the same, have the same criteria, where it is also used in the higher calorific value and slow burning rate. So as I told, pellets will be having a consistent size, high energy density, and burn with little emissions. So briquettes are extensively used in cement manufacturing, brick kilns, and power plants, and also some other food and beverages manufacturing, as I told, wherever the boilers are used. Coming to the investment analysis and the government support. The pellets chart, hope you can see the capacity considering 4 tons per hour. It's not that the minimum capacity, it can be done, it can be started through 1.5 to 2 tons per hour as well. So considering 2 shifts per day and 20 hours of working days, and we'll go for the higher side of the pellets. The capital would be will be around 3.5 to 4 crores. The capex, and for the briquettes for the same capacity, it will be around 2.8 to 3.6 crores, and production cost will be around 4.5 to 6 rupees per kg. And whereas in terms of briquettes, it will be 4.5, almost similar. And selling price of pellets is around 8 to 10 rupees per kg, and briquettes is around 7.5 to 9 rupees per kg. And margin you can expect around 2 to 4 rupees. So 4 rupees, how you can expect that will be explained in the next slide. And briquettes 1.5 to 3.4 rupees, as similar to that. The And coming to the ROI, you can expect the ROI around 1.5 to 2 years. Marginally, it will be around 2 years. And briquettes around 1.75 years. So land required, the minimum land required would be on 25,000 square feet, similar to the briquettes also. And coming to the central government initiatives, so the Ministry of New and Renewable Energy have identified a policy of National Bioenergy Program, under which they are providing for briquettes 9 lakh per metric ton per hour capacity, and the maximum limit is up to 45 lakhs per project. So for the non-tarified pellets plant, 21 lakhs per metric ton per hour, up to 1.05 crores per project. And for tarified pellets plant, 42 lakhs per MTPH, up to 2.1 crore per project. So the major difference between the non-tarified and tarified pellet would be the moisture content, where tarified pellet plants, the moisture content is very low. You can take up to 2 to 3%, and tarified pellet will be quite higher. Non-tarified pellet will be quite higher. And there are still technologies have been going on to convert from the non-tarified pellets plant to tarified pellets plant across India. And many technology enthusiasts are working on the technology part as well. Next slide. Yeah. So the most important criteria here is the gross calorific value to select the raw material. So as you all know, in the power plant, thermal power plants, the material used is the coal, which has the very high gross calorific value. So the government of India have given, under the green energy scheme, so they have initiated with this opportunity for the manufacturer to go with the green, and then they have initiated 5% to add pellets to the thermal power plant to mix it with the coal. So those pellets should have the calorific value at least more than 3,800 GCV value. That is because the burning the burning calorific value should be very high when it compared to the coal as well. Hence, you can see the chart over here, which has the most calorific value. Coming to the first column would be woody biomass, where hardwood like oak, maple, softwood, which is around 3,600 to 4,800 range. Sawdust is extensively used across the South India, especially Tier 1 and Tier 2 cities. And bamboo is used. Bamboo also has a higher calorific value, but it is raw material where the bamboo is available. There places can be used, especially in the northern Karnataka and the Andhra Pradesh region and Assam region, where most number of bamboos are available. And coming to the agricultural residues, sugarcane bagasse, which is very less, and rice husk also can be manageable, and rice straw also very less. So wheat straw has a very high calorific value, and corn stover, corn stalks and all. So coconut shells is extensively available in southern India, and it has a very high calorific value, and it is available whole through the year. And coming to the groundnut or peanut shells, which can also be used, mustard stalk also. But here Napier grass have not been mentioned, but Napier grass has the calorific value in the range of 3,900 to 4,300, which can be used as a major raw material as well. So coming to the location identification. So here the technology or the machinery commissioning will not be a difficult thing, especially in both, if you take bio-CNG or biomass both. The major criteria or the major hurdle will be at the initial process. That is to identify the location. So how do you identify the location which can be used extensively is the location has to be nearby to the raw material source. Here for that concern, we have taken Napier grass as the source, but any other agricultural residue can be used as a raw material, which I explained in the last slide, which has the highest calorific value. The other major criteria is the location has to be nearby to the any NTPC or state-based thermal power plants. That is because to reduce the raw material cost and the transportation cost, where you can decrease the production cost and increase your profit margin, as I told in the previous slide. So these are the two major criteria. So if you take Napier grass as the raw material which can be used, say for example, if you are going for 2 to 2.5 tons per hour capacity of the pellets plant, consider you required to grow the grass at least 70 to 80 acres of land is required, and 2 to 3 acres, 45,000 square feet, up to maximum 1 acre of land is required for the construction of the plant, and including the storage area. And this plant, if it is nearby to the any of the NTPC plant, so that would be very useful for the transportation, and even the NTPC will also be very happy to give the the pellets opportunity for you to serve the NTPC power plants. So yeah, that was about the biomass, pellets or briquettes. So biochar, coming to this biochar, it's still an extensive technology has been going on, and biochar it has various applications. Many places it can be used. So the major technology involved is the pyrolysis process, where biochar relies on the pyrolysis. So in the absence of oxygen. So if we heat up to 350 to 750 degrees Celsius in the absence of oxygen, so the final product obtained is the biochar, and the other byproducts can be obtained, which is obtained as syngas and the bio oil, which is considered as a renewable energy source as well. So these are some of the crop residues that can be used, that is castor or pigeon pea, sorghum, rice straw, rices, are similar to the biomass pellets as well. So coming to the applications part, so the versatile applications where biochar can be used are soil health and fertility improvement, as Mr. Shivshankar sir explained, and livestock farming, water filtration, soil and land remediation, waste management, construction and building materials. Even nowadays, the technology have been extensively used in electronics also, and textiles, cosmetics. Cosmetics is a very old thing where biochar has been used extensively, and even heating applications. So coming to the other raw material sources, agricultural residues, as we saw in the last two products as well, like woody biomass, poultry waste, dairy waste, paper waste, urban aquatic biomass, kitchen waste, animal and human, industrial and paper mill waste as well. As we have seen the biomass here in biochar also, where you can start the biochar as per the location. So coming to the strategic resource adjacencies, you can start where nearby sugar mills are there, proximity to the high rice husk supply, and any other place like adjacent to edible oils, close to sawmills or furniture, and paper and pulp mill integration are there, where raw material sources available extensively. And the second is the agricultural powerhouse region. The regions being Punjab, Haryana, Western Uttar Pradesh towards the west, and cotton belts like Telangana, Gujarat, Maharashtra, and Karnataka, corn regions like Karnataka, Madhya Pradesh, and also areas with forest management activities going on. And the other criteria is animal husbandry integration. So near large poultry farm clusters and adjacent to dairy collectives, proximity to goshalas, regions with established manure handling. So the final one is the forestry and the wood processing. So near sawmills and furniture manufacturing, paper mills areas and all. So critical site selection factors. The main thing, as I told, feedstock availability, abundant, consistent year-round. The feedstock should be available abundantly across the year, and logistics and transportation, good road facility. These are the general criteria. End market proximity, close to the large firms, the applications as I told before, and utilities, access to electricity, and land and permitting. So availability of affordable industrial land and labor, access to the skilled and unskilled labor at that point. Usually unskilled labor would be considered, and proper training has to be provided. So yeah, coming to the investment analysis as per the application wise. So if you are considering for a medium scale manufacturing, so production parameters, input feedstock would be 10 to 15 tons per day, and biochar output can be expected around 3 to 4 TPD with a good organized raw material selection procedure. So primary market is agricultural sector. So facility agricultural sectors, as I explained in the previous sector on the applications wise. So what are the facilities required? Land required is around 2 to 3 acres, and the technology or the machinery would be semi-continuous or a rotary reactor. Financial metrics, capex would be around 2 to 4 crores for the biochar output of 3 to 4 tons per day, and annual opex can be would be around 75 lakhs to 1 CR. So break even can be expected to 3 to 4 years. Coming to the large scale manufacturing, so if you are an existing businessman, environmental enthusiast, it's a very good opportunity where input feedstock would be 50 tons per day and output can be expected around 15 tons. So target market is industrial heating applications and other cosmetic companies. So facility required is land required up to 5 to 8 acres maximum, and here the machinery would be fully automated continuous plant. So the financial matrices will be as capex around 15 crores, opex 5 CR, and break even can be expected around 4 to 5 years. So these are the essential equipments where hammer mills, rotary drum dryers, vibrating screens, screw polymers, heat exchangers, grinders, and packaging. So these are the general equipments or the machinery which is required. So this is about the biochar and the biomass pellets or briquettes. So it's a very good opportunity for the energy enthusiasts to enter into the energy sector, where you can establish yourself as an under the green energy as a carbon creditor also. And coming next slide. So upon this, before going to the question answer section, we have poll questions over here. So yeah, we have published the poll. You have 2 to 3 minutes, up to 5 minutes, so you can answer the polls.
As people are answering the poll, maybe you can take a look at some of the questions.
Yes.
One question that comes to mind typically from an entrepreneur is, many states are offering policies. So if Shiv Shankar sir is there, then can you see and tell us, why an entrepreneur should be choosing Karnataka over other states? What are the more benefits he can expect? Shiv sir, are you there? Maybe he is busy. No, he's there. Yeah, sure, sir.
Few minutes, I'll just join.
Yes, sure, sir. So the question is basically, if somebody entrepreneur, we have so many entrepreneurs on the call today, if they are looking at setting up a plant either in bioenergy or it could be CBG, what are the things that they can expect more from Karnataka state government?
Am I audible now?
Yes, sir. Yes, sir.
One thing is the present Karnataka industrial policy 2025-30 is in effect. So the incentives and the support from the policy, along with it, the board will be in a position to assist the investor in finalizing the area. Example, he has an option of 2 or 3 areas. So we can help them in identifying the right area and connect them to the biomass bank so that they need not interact with individual farmers day in and out, because every industry may need a minimum of 100 to 200 farmers for their functioning, and there will be issues with the farmers. So be supporting them and bringing in a biomass bank so that the biomass bank interacts with the industry, and the biomass bank has a as the farmers also. So the industry need not directly involve with the farmers, but the biomass bank will be of a progressive and a industrial inclination farmer group or an individual.
Right.
And secondly, what are the technologies which are presently existing, and the knowledge what we have, we can share with them, and also arrive at a consensus that what is the best technology which can suit to the location. Thank you.
Thank you. Thank you, sir. So I think a little bit more on these points. You have a very good, aggregator policy wherein these aggregators will be the ones who will be talking to FPOs and the farmers and having a pool of, farmers who are ready to supply raw material. And the industry need not go to individual farmers or individual FPOs and get these raw materials, since there are aggregators already who have been identified across various districts of Karnataka. This is something that is going to benefit the industry and take some headache of from him, wherein the aggregation of the raw material will be possible. Thank you, Shiv sir.
Thank you, sir.
Thank you.
So we have a question for Ms. Sejal. So a very first question. Is this process of increasing gut health in the cows for high quantity or quality of microbes cost efficient?
Yes, it is very cost efficient. I mean, now through our project, we have generally the non-milking cows daily feed cost ranges from 100 to 150 rupees, and for milking it is 250 to plus. So by following all of these practices, maybe it includes some capex, that is also not much, but yeah, but the cost is reduced from 150 to 50 rupees, and same way from 250 rupees to 50 rupees. So we drastically reduce the cost of feeding.
Okay. And there is one more question for you, ma'am. How much ton can we generate in 1 acre?
So practically we have generated more, but for any new land or anything, we need to first check on we need to do the analysis. Based on that, we need to understand the package of practice, but easily can generate 500 to 600 tons per acre per year.
So someone has for the bamboo in relation to biochar. That will be explained on the one-to-one discussion with our expert. Cost of raw materials, approximate cost of raw materials. So cost of raw materials, especially for biomass pellets, will be different for different raw materials. As I explained, if you are going with the farming land as well, say consider any raw material, so you can reduce the production cost out of it and parallelly increase the ROI expectation as well. And as Shiv sir told, especially in Karnataka, so they are planning a biomass banks through NGOs in some of the major districts across the state, where through them the farmers also can have some regular income, maybe weekly as well, or 15 days once, and by then manufacturer also will get output of the input of raw materials very regularly. Where will
Yes.
we find
And also it is, right now, since this sector is in the, starting stages, a lot of policies are being made as we even discuss. So if you look at, even Karnataka government's policy, the existing policy which was there has been completely revamped, and we expect in the next 1 to 1.5 months for the new policies to come in. And each policy which is being made is making sure that the problem of gathering the raw materials is being addressed, because see, if you look at it, Satat has been a very old scheme. It has been started in 2018 and I think revamped again in 2022 once. but the offtake was low, as in not many units were set up. The reason being that many times what was happening is, you know, the entire concept of CBG was being promoted more from a social angle, as in, you know, you will be using the municipal solid waste and basically making energy from waste. And that's why, you know, not many entrepreneurs were coming in. Because let us be very frank, an entrepreneur to set up a unit, he needs to know how fast he can get his money back, what kind of ROI he can expect. With the advent of you know, very strong raw materials, I can say, like Napier grass and you know, the super Napier, and advancement in technology for the digester by itself, this has become more feasible, and I would say more economically viable than what it was a few years back. So if you look at you know, the existing policies or the old policies were more towards you know, what kind of rates you can expect if you take municipal solid waste. In fact, if you look at your cost of raw material when you are using municipal solid waste, in some cases it's even negative, as in the government is paying you to use the solid waste. But no more that is the, you know, case, because obviously you know, you have to look at the composition of the solid MSW. Many plants, you know, who are taking MSW as their sole input, are not able to have 100% efficiency or high efficiency, only for the reason that you do not have control over the raw material. To give a very basic example, see, when it rains, or typically 4 to 5 months when there are monsoon, your quality of you know, waste that is coming in is has very high moisture content. Now in that case, although they say that they will cover the entire this one during the logistics, or the trucks will be covered and things like that, but it is not always possible. So in that case, as and when you do not have control over the raw material that you are feeding into the digester, your end product, that is the gas that is being produced by the microorganism, will also suffer. So to, you know, overcome or work around for all this, we are trying to see if we can, you know, have you know, kind of an integrated plant where organic waste is also one of the input. Along with that, when we have Napier, super Napier and things like that, we will be able to get at least consistent you know, output from the reactors.
Thank you, sir. And ma'am, for you, so as a farmer and not as an investor, so what's takeaway for them? Let's say they have 5 to 10 acres of land. Can he be part of the team and get benefit of these programs like CBG or biomass?
So in that sense, it depends again for if there are already some pellet productions or CBG going on, one can be a supplier of Napier grass to them because they are purchasing Napier grass, right? So that can be one way, but with the condition that it has some nearby plant manufacturing unit, so the transport can be viable.
Okay, okay. So yes, I hope everyone enjoyed the session and took proper guidance on the energy sector, and as well as the to what kind of organic farming can be chosen to your land if you are a farmer or an enthusiast in the farming accent as well. So by this we have successfully finished 7 sessions from past 4 days. So I would thank everyone who has for all the participants and attendees who has attended. Thank you very much. And further, we will be guiding you in the process of identifying. We have also seen some questions over there, how to identify the exact raw material or the location. So we would be guiding further on those things as well, and as well as the complete plan setup assistance. It might be starting from the documentation, DPRs, or the subsidy guidelines, whatever it is required, and plant setup assistance as well, and finally to the trial production stage, and convert, and also for the private opportunities, if it is there, we can guide to the sales and marketing opportunities also in the private sectors. So thank you everyone. We will be reaching you out in the video consultation session as well for further assistance.